Hello everyone, I'm Shihab, and today I'm going to prove Newton's second law using the Lagrangian and using the concept of the energy and the relationship between the potential energy with the force, considering this proof a free particle in Cartesian coordinates. So we are dealing with Cartesian, so we can write the kinetic energy T 1/2 mv squared. So we can write 1/2 m. V square is x dot square plus y dot square plus z dot square, because we are dealing with Cartesian coordinates. And we want to express the potential energy also in Cartesian coordinate, but we can just write it as u of x, y, and z in a general notation, because we are just saying it's a free particle. We don't know what potential energy is affecting on it. So the Lagrangian, by definition, is the kinetic energy minus the potential energy. So 1/2 m x dot square plus y dot square plus z dot square minus the potential energy as a function of the position. So we are looking for the Lagrangian equations of motion. So we are taking the partial derivative of the Lagrangian, the first position x, and then this will be equal to the time derivative of partial Lagrangian by partial x dot. And we are taking partial Lagrangian by partial y, the second position variable, and similarly for z. For the first one, we will take the Lagrangian here and differentiate it with respect to x. And because we know we don't have x here in the kinetic energy, we are just looking for the potential energy. It will be minus partial u by partial x equal d by dt, partial Lagrangian by partial x dot. X dot is just here in that term. So taking the derivative, this will be m x dot. And because the particle mass doesn't change with time, so m here is just a constant. You can pull out m and differentiate x dot with respect to t. This will give us x double dot. So this is the first part. For the second part, we have y position and z position. And because we have the same thing here, y dot square, z dot square, and this potential energy is dependent on y and z, in the same way it's dependent on x. So we can find similarly the second equation of y also for z. So these are the three Lagrangian equations. Well, how to use these equations to prove Newton's second law? We know that F vector is equal to minus gradient of the potential energy. So this will be minus partial u by partial x I hat minus partial u by partial y j hat minus partial u by partial z k hat. And using these equations, we just substitute. So mx double dot I hat my double dot j hat mz double dot k hat. Taking m as a common factor, m times x double dot I hat plus y double dot j hat plus z double dot k hat, and that thing is just the acceleration vector for Cartesian coordinates. So f vector equal m a vector